This is a report on OpenRefine prepared for Dr. Mary Bennett by me, Alexandra Thornton, Learning and Research Special Projects Librarian for the William Collins Central Library, University of Netherfield. OpenRefine is a free open source software. It was released by Google to the open source community in 2010. It's licensed under the BSD license and it's available from openrefine.org or from GitHub. It's a tool that can be used to make any data more consistent and therefore easier to manipulate. The OpenRefine website describes it as a powerful tool for working with messy data, cleaning it, transforming it from one format into another, and extending it with web services and external data. By default, OpenRefine supports various file types, and by using extensions, it supports other formats such as MARC. OpenRefine is well understood and tested technology. It has proven useful in information services worldwide. Some academic libraries using OpenRefine include this. Before I started testing OpenRefine, I was guided by Hella from Loyola University Chicago Library in looking for multiple types of abbreviations, extra spaces, extra punctuation, and outright misspellings, and by Weeks at St Olave's, who used OpenRefine to remove stray white spaces, remove stray characters, cluster similar terms and reconcile them, and automatically match records to records in a linked data service. So how did I test it? I followed the Using OpenRefine manual by Verborg and de Wilt. So I installed the latest version of Java. I installed OpenRefine 3.0. I downloaded a dataset from the Powerhouse Museum to see how OpenRefine works. I downloaded a dataset from the British Libraries called Digitised 19th Century Books Metadata that has more relevance to our library. And then in OpenRefine, I loaded the British Library dataset, created a new project, explored the dataset for things to clean, and used OpenRefine to clean that dataset. Here's a quick demonstration. Okay, so here we have the British Library book data CSV file that's been created as a project inside OpenRefine, and here it's rendered inside a browser, Firefox in this instance. So we have our set of records. We've got 47,980 records. We can go through using OpenRefine and look for anomalies. So I'd like to show you two basic functions. One is the text facet, for which we're going to use the publisher. So we select Publisher, Text Facet, and over here it shows us that we have 7,119 publishers listed in these records. Now that's too many to do anything with, so we're going to facet by choice counts. Now here we can select the number of records to which this applies. So we're going to select as a minimum 1,000, and then we can look for anomalies. So I've had a quick look through here before, and I know that there's an anomaly down here. We've got Goose and Goose & Co. Now they're most likely the same record. So I'm just going to delete that and go apply. So now you can see we have two Goose records. Another aspect of OpenRefine that I'm going to show you that's quite powerful is the numeric facet. Now the date, all of those dates should be numeric. I selected to convert the cells to numeric data when I converted the CSV file. So let's select that. Now here, this is a slightly different operation. We don't need to limit it by the bars up here, but instead we can have a look at the records. So we apparently have 70 records with a blank date, so we'd really like them to all have a date. So let's have a look at those records. Now the top one here actually does have a date. There must be something wrong with that entry, and if we have a look at it, we can see that the data type is text. So let's change that to a number and apply it to all identical cells. What about this one here? It has the same problem. So again, we can go through, make these changes that will make our records cleaner. So we can continue in this way, looking through all of the fields to try and tidy up our data. And that's the end of this quick demonstration. So what are the advantages and disadvantages of OpenRefine? I think it'll be useful for any project that requires us to transform our data to keep up with new technologies. There are recipes specific for librarians available from GitHub, so there's lots of prior knowledge out there which is very helpful. Within a project there are multiple levels of undo, so experimentation is basically without risk, and I cannot see any disadvantages with this product. We can use it for individual projects as and when required. So the skills required: if you understand how to use spreadsheets, you'll understand OpenRefine. Google provides 3 excellent short introductory videos on the homepage of openrefine.org which get you started. And the manual, as mentioned, using OpenRefine provides an in-depth look at using OpenRefine, taking you from basic to advanced use. There's also a one-day OpenRefine course developed by Owen Stevens of the British Library. In terms of security risks, because it's a standalone desktop Java application, there are a few security risks. We would install and run it locally so our data remains on our premises and no one else can access it any more than they can anything else on our servers. There's no risk to our actual data. We would use a copy of our data, and with multiple levels of undoing, the program can always return to the base data set anyway. I could find no reliability problems with OpenRefine in the academic literature. Searching the FAQ for the OpenRefine repository on GitHub showed a few problems that are common to Java programs and large datasets. These are solved by installing the correct JRE and assigning at least 1 GB of RAM more for very large datasets. I actually increased my allocation to 3 GB to work with the British Library dataset. As I've shown, OpenRefine will be useful to us. It's a free and open source tool with all the attendant benefits. At compilation of this presentation, the OpenRefine project in GitHub had 6 active developers, over 1,000 forked versions of the code, more than 5,000 likes, and the codebase was last updated 2 days ago. Further, the literature suggests that it is quick to implement and easy to learn, with many free resources available to learn how to use it. It has a proven use in information services. It is an innovative way we can help address budget constraints and make our procedures and services more sustainable. Our library can use OpenRefine to help us improve the quality and design of our metadata. This in turn will help us to make our catalogue available through web portals and our library collection more discoverable on the internet rather than patrons having to use our library gateway. More specifically, we could test linked data with the bibliographic records for our unique collection of pre-1990 academic works from Austin. Here's a list of references for this presentation, and thank you for your time.